Imagine, if you will, a character who looks up at the sky and thinks, "Blue is so yesterday. Let's shake things up." Picture this character as an eccentric artist, armed with a giant paintbrush, determined to add a splatter of red or a swirl of green to the vast canvas of the sky. He dips his brush into a bucket of vibrant paint, and with a grand sweeping motion, he paints across the sky. But alas, the sky remains its stubborn shade of blue, not a hint of change in sight. Undeterred, our artist tries again. Maybe a different color will do the trick? Yellow, perhaps, or pink. But no matter how much he paints or how many colors he uses, the sky remains its usual tranquil blue. It's almost as if the sky is laughing at his attempts, a canvas that refuses to be changed. With each failed attempt, our artist's frustration grows. Why is the sky so persistently blue, he wonders. And that's the million-dollar question, isn't it? Why is the sky blue? It's a question that has puzzled many a curious mind, from toddlers asking their parents to scientists in their laboratories. But fear not, for it's not all in vain. Our artist's failed attempts have set the stage for a fascinating journey into the world of light and color. A journey that will take us from the surface of the earth to the farthest reaches of the sky and back. A journey that will reveal the secrets of the sky's alluring blue color. So, while our artist's paintbrush may have been a fruitless tool in our quest to understand the color of the sky, science, on the other hand, has plenty to offer. Get ready to dive into the fascinating world of light scattering, atmospheric particles, and color perception. Buckle up, because we're about to embark on a journey that's as colorful as our artist's palette. Well, our friend's paintbrush may not be of any help, but science sure is. Buckle up, we're diving into the world of light scattering. The sun sends out light, but it doesn't arrive on Earth as is. There's quite the dance happening in our atmosphere. Our sun, a burning ball of gas, sends out light that is essentially a mix of many colors. When this light hits the Earth's atmosphere, it interacts with the molecules and tiny particles in the air. The sunlight, which was once a unified front, now finds itself scattered in all directions. But here's the catch. Not all colors are scattered equally. This is a principle known as Rayleigh scattering, named after the British scientist Lord Rayleigh, who first studied it in detail. This scattering is more effective at short wavelengths, towards the violet end of the spectrum. So why then, you may ask, does our sky not appear violet? That's because our eyes are more sensitive to blue light, and because sunlight reaches us with much less violet in it to start with. Moreover, some of that violet light gets absorbed in the atmosphere, then gets re-emitted in different directions, a process known as fluorescence. In other words, the blue and violet light from the sun that reaches us here on Earth gets bounced around the sky by the oxygen and nitrogen molecules in our atmosphere. The blue light gets scattered more because it travels in smaller, shorter waves. Imagine a crowd of people and a group of children trying to make their way through. The children, being smaller and more agile, are able to change directions quickly, darting this way and that, much like the blue light. The adults in the crowd, however, move in more or less a straight line, much like the longer red and yellow light waves. So, it's the tiny oxygen and nitrogen molecules scattering the short blue and violet light to the sides and around the sky. This dance between sunlight and our atmosphere paints our skies with a beautiful blue hue. And now you know it's not magic, but a symphony of physics. But wait, if violet light scatters more, why isn't our sky violet? Well, that's a great question. Our eyes are the main culprits here. You see, we humans have 3 types of color receptors, or cones, in our eyes. One for red, one for green, and one for blue. These work together to help us perceive a wide range of colors. But unfortunately, our eyes are less sensitive to violet light and are far more responsive to blue light. So, even though the sun emits more violet light and the Earth's atmosphere scatters it more than blue light, our eyes pick up on the blue more. It's like going to a party where your favorite celebrity is present, but you end up noticing the second most famous person more because they're simply more familiar to you. That's what our eyes do. They notice the blue more because it's more familiar to them. Now you might be wondering, but the sky isn't always blue. But what about those gorgeous red and orange sunsets? And that's an excellent observation. The color of the sky can change based on the time of day, weather conditions, and even your geographical location. During sunrise or sunset, the sun is at a low angle, meaning its light has to pass through more of Earth's atmosphere. This longer path allows the atmosphere to scatter away most of the shorter blue and green wavelengths, leaving the longer red and orange wavelengths to reach your eyes. It's kind of like the atmosphere putting on a grand color show for us every morning and evening. On a cloudy day, the sky might appear gray. That's because the water droplets in the clouds scatter all colors of light equally, resulting in a white or gray sky. And if you're lucky enough to be in a place like the North or South Pole, you might get to see some truly spectacular sky colors due to phenomena like the aurora borealis or aurora australis. And that's why most of the time, we're under a blue, not violet sky. But the sky isn't always blue, right? Sometimes it throws a bit of a color party. Indeed, the sky can often surprise us with a fascinating palette of colors due to unique atmospheric and astronomical conditions. Consider the enchanting spectacle of the auroras. These are natural light displays predominantly seen in the polar regions. They occur when the solar wind, a stream of charged particles released from the sun, interacts with the Earth's magnetic field. This interaction excites the atmospheric gases, causing them to emit light. The result? A mesmerizing dance of greens, pinks, purples, and blues lighting up the night sky. Then we have the phenomenon of light pollution. This is the brightening of the night sky caused by streetlights and other man-made sources. It interferes with astronomical observations and disrupts ecosystems. But it also radically alters our perception of the sky's color, often giving it a hazy, orange glow. Interestingly, the color party isn't just limited to our planet. Other celestial bodies have their unique sky colors too, thanks to their distinct atmospheres. Take Mars, for instance. Its sky is not blue, but a kind of butterscotch color during the Martian day. The fine dust in the Martian atmosphere scatters sunlight in a way that gives the sky this color. And during sunrise and sunset, Mars treats its viewers to blue and green hues instead, the exact opposite of what we experience on Earth. Even our neighbor, Venus, flaunts a yellowish sky due to its thick, sulfuric acid-laden atmosphere. And if you ever find yourself on Titan, Saturn's largest moon, you'd look up to see an orange sky, thanks to its nitrogen-rich atmosphere filled with organic particles. So while our sky mostly prefers blue, it does like to change things up from time to time. Whether it's the shimmering colors of an aurora, the hazy glow from light pollution, or the unique atmospheric hues of distant planets, the sky's colorful moods are a constant reminder of the complex and beautiful physics at play in our universe. Now that we're sky color experts, let's clear up some common misconceptions. One widespread belief is that the sky is blue because the ocean reflects its color. It seems like a simple and logical explanation, right? But in reality, this is a classic chicken or the egg scenario. The ocean appears blue because it absorbs colors in the red part of the light spectrum more efficiently than the blue part. So in essence, the ocean is mirroring the sky, not the other way around. Another common misbelief is that pollution or smog makes the sky appear blue. This is also a myth. While pollution can indeed affect the perceived color of the sky, it does not cause it to be blue. Instead, it can make the sky look hazy or gray, especially in urban areas. The scattering of sunlight by air molecules is what gives the sky its blue color, not pollution. Some also believe that the sky is blue because the Earth is surrounded by a vast, blue ocean of air. However, if that were the case, wouldn't the sky be blue everywhere, even at night? The truth is, the sky is not inherently blue. The color we see is a result of how sunlight interacts with our atmosphere. Lastly, you might have heard that the sky is blue because of the reflection of water vapor in the atmosphere. This belief is also misguided. Water vapor in the atmosphere can indeed influence the color of the sky, but it doesn't make it blue. Instead, water vapor can create stunning displays of colors, such as rainbows. So, the next time someone tells you the sky is blue because of reflected ocean water or atmospheric water vapor, you can gently correct them with your newfound knowledge. Remember, the sky's blue color is primarily due to Rayleigh scattering, where shorter wavelengths of light, like blue and violet, are scattered more than longer wavelengths, like red, orange, and yellow. And there you have it. No more living under false sky color beliefs. Enjoyed our sky color journey? Want more bright ideas and blue discoveries? Well, you're in the right place. This is your one-stop channel for all things curious and intriguing. From the depths of the ocean to the heights of the sky, we delve into the mysteries of the world around us. So if you're a seeker of knowledge, a fan of fun facts, or simply someone who appreciates the beauty of the natural world, click subscribe and never miss a chance to learn something new and fascinating. Let's revisit our journey to answer why the sky is blue. We began with a simple curiosity, a question that has puzzled many of us since childhood. Then we delved into the dance of sunlight with Earth's atmosphere and how this interaction, known as Rayleigh scattering, paints our sky with a blue brush. We discovered that it's not a matter of blue paint, but of blue light. Sunlight, a spectrum of many colors, interacts with the tiny oxygen and nitrogen molecules in our atmosphere. The shorter wavelengths of light, specifically blue and violet, are scattered more than other colors because they travel in smaller, choppier paths. This scattering sends blue light in all directions, and our eyes pick up this blue light from every part of the sky we see. But what about violet, you ask? Well, our eyes are less sensitive to violet light, and our brains are more inclined to perceive blue. Plus, sunlight reaches us with less violet to begin with. We also explored the changing moods of the sky. From the radiant red and orange hues of sunrise and sunset to the rare and spectacular colors caused by unique atmospheric and astronomical conditions, our sky is a canvas of ever-changing beauty. We debunked some common misconceptions too, like the idea that the ocean's color is a reflection of the sky. It's actually the other way around. The blue in the sea is the result of the same scattering of light that happens in the sky. Our journey through the world of light scattering and sky colors has been enlightening, to say the least. We have not just answered the question, why is the sky blue, but we've also understood the scientific principles behind it. Next time you look up, you'll know exactly why the sky wears its beautiful blue. Got any cool sky observations? Let's chat in the comments.